Welcome to Module 5, Lesson 12, where we are now comparing fractions. Which one's larger, or are they equal? And we're going to do that using the number line and benchmark fractions. Now there are about... I hope things are going well with this video. I am having to learn a new program, so there are some errors that I'm making, and I'm kind of slow. So be patient with me, and I'm doing the best I can, and it'll get better. What's bigger, 2 or 4? Now, a lot of you are like, well, 4 is bigger, Mr. Osborne. That is the easiest question you've ever asked. But why is it bigger? How could you explain, how could you teach to someone else that it's bigger? I think one automatic response would, you guys could say, well, this would be 2 items, and this would be 4 items, and 4 items is more than 2 items. That's great. That would be like drawing to explain your answer. You could also explain your answer by using the number line. You could say that integers start at 0, and then as you count up by ones, the farther away from 0 you get, the larger your number is. So here's a 2, 2 hops away, and here's a 4, 4 hops away. 4 is farther away from 0, and therefore it is larger. Now in the opposite direction, it's kind of interesting because the farther you get from 0, the more debt you have. In the positive direction, the farther away from 0, the more you have. Now today we are comparing fractions. So it's not as easy as comparing 2 versus 4, because fractional pieces are a little bit more challenging, but there are several great ways. In fact, my class looked at 6 methods on how to compare fractions. In this video, you are going to look at 2. Only 2, because it matches the homework, and I want to keep it simple for the first lesson. But yes, there are lots of methods for comparing fractions. Now this first one that I just showed you right here, the number line, is where we're going to start. Look at this first question on your homework, where it does ask you to plot 2/3, 1/6, and 4/10 on a number line. Now the number line's already marked for you from 0 to 1. These fractions do all exist in between 0 and 1, so they go on there somewhere. Now figuring out where they go can be done a lot of different ways. I told a lot of my students to start by looking at these numbers here on the bottom, these denominators. And usually it's easier to start with the smallest one. And you can see that the 3 here is the smallest denominator, thirds. It's not too difficult to put our number line into thirds, right? If it was a tape diagram across right here, we would put thirds, and maybe not right there. Pretty close to right there. And you should know, as you can see right now, that I'm not completely accurate. We're estimating. I want these fractions close to where they should be. They might not be in the exact perfect spot. So there's thirds, right? Your number line should probably have a third marked here and a third marked here, and this would be 1/3, and this would be 2/3. You need to have the 2/3 marked, so you could write the 2/3 here. You could circle it to show that that's where it's at. Now how could you turn thirds into sixths? Isn't the denominator just doubled? So if it's just doubled, you would double your pieces by putting marks in the middle. So this first mark here would be 1/6, 2/6, 3/6, 4/6, 5/6, and the whole would be 6/6. So we already said, what do we need? The 1/6. Your 1/6 would be right here. So we have found the 2/3. We have found the 1/6. Now we haven't put the 4/10. Now let me tell you, you can't really move from 6, like we drew here, to tenths. 6 doesn't double to 10. So how you're going to find the tenths can be very tricky. Now here is what I would suggest you do. Use your benchmark angles, or fractions, angles. Use your benchmark fractions. Right now at this point, for fourth graders, your benchmark fractions are probably 0, half, and a whole. Now, some of you probably know a fourth really well, and you probably know 3/4 really well. But I really want you to focus on the half. You guys know halves really well. You know that if the top number, 1, is half the bottom number, 2, then you've created a half. So other halves might be 5/10, or 50/100, or 10/20, or 2/4. What about this number, 4/10? What would have to be on the top to make this a half? What would be half of 10? Well, half of 10 would be 5/10. This 5/10 is half. 5/10 is equivalent to half. These two would be in the same spot on the number line. Now that's very important because 4/10 is a little bit less than 5/10, isn't it? If you had 5 apples, you have more than 4 apples, but just by a little bit. So 4/10 you could estimate is right here before the half mark. And that is close enough to do on this problem. You have now looked at how far these fractions are from 0. I've got kind of a mess here, but bear with me. Let me change colors, maybe make it a little easier to see. Here's 0. 1/6 is a little bit a ways. 4/10 is a little bit farther. And the farthest away is 2/3. You just found how big these numbers are in order from smallest to largest. And now you could use the number line to do the second part, B. So B says use the number line to compare. Well, how does 2/3, the number right here, compare to 1/2, the middle? Well, 2/3 is farther away, so it's larger. So go ahead and say 2/3 is bigger. And 4/10, the one that we just worked on figuring out, it's right here. How does it compare to 1/6? Well, 4/10 is farther away than 1/6, so it is larger. So you put the greater than sign. All right? So if you could accurately put fractions on a number line, you could tell which ones are larger. That is a very good method to really explain which fractions are the largest, which ones are the smallest, and if any are equal. Now, they don't want you to use the number line. They want you to use the benchmark half. If you know what fractions would be a half, how to make halves, you know which ones are smaller or larger than halves. For example, on the very first one, you have a half already written here. And then the fourths are only 1/4. Now what would make this a half? Wouldn't the top have to be 2/4 to be half? But this is only, this is only 1/4. 2/4 is more. The number 2 is more than 1. So 2/4 is bigger than 1/4. Therefore 1/4, it's smaller than a half. So you would have to say that a half is larger than a fourth. And yes, in the directions, it says to tell in words which one's bigger and why. So we told you which one's bigger, and they would want you to explain something like this. Let me type in here. 1/4 is larger than 2/4. See, so an answer like this tells me that you were trying to compare to a half. Do not just write your answer is half is bigger than a fourth. Well, no, yeah, I know. That's what this told me. Tell me where you got it from. Okay? Well, let's try a couple more as examples. You might be wondering, wait a minute, this is really hard. Let's do B here. 6/8 and a half. Now, you already have half given. What would make 6/8 half? Wouldn't 4/8 be a half? Because 4 is half of 8? Yes. But this is 6/8, which is more than 4. So this is larger than half right here. And so again, you would say something like 6/8 is larger than 4/8. 6/8 is larger than 4/8, which is 6/8 is larger than the half. Now, in situations that I see a lot here, 3/4 versus 3/5, I would say both of those are larger than half. So at this point, you would have to use a trick. Now, the trick isn't going to give you much meaning and much depth, at least not for today, but you're going to have to use the trick called cross multiplication. In this, you multiply the numbers diagonally. So you multiply the 5 times 3, and you get 15. And you multiply the 4 times 3, and you get 12. And then you look at those two numbers and say 15 is larger than 12. Therefore, the left side, looking for my eraser here, don't seem to have one, there. Therefore, the left side is larger than the right side. 3/4 is bigger than 3/5. And for this one, for homework purposes, you could say I used cross multiplication. I cross multiplied. Okay? Do that for the ones that you can't make halves out of. I'm okay with that. So I'm okay with you doing that on D. I'm okay with you doing that on F. On this one right here, you can compare halves. 2/4 would be a half. 1/4 is less than a half. Therefore, this side is smaller than 2/3 because 2/3 is more than a half of something. All right. We've just scratched the surface of comparing fractions. It might be a little difficult tonight. If you have more questions, see me, and I'd be glad to help. Otherwise, we are going to keep practicing this for several days. All right. Thank you.